All right. So we are going to start with basics today. But it's important for you to know what I'm teaching today, so you know in the future when it gets more complicated, you know what to do. Okay. So let's have this object. Okay. It is a three-dimensional object. You can draw it in different ways. But I want to draw the sides to show you how each side looks. Okay. Grade 10s, thank you. We use orthographic projections, okay, to do this. Now, orthographic projections is basically explaining how something's looking from this side, how it looks from this side, how it looks from this side, and here, and even from above, okay? So this thing, this object that has multiple sides, you need to be able to draw on each side, okay? Now, I know it sounds very weird and basic, but it gets complicated. So I'm going to show you on this paper. Basically, if you have a three-dimensional drawing such as this, you will need to draw it in a certain way to ensure that it matches up. Okay? So in reality, the front view would look like this. Okay? Because it is that side. This on the right side. So where the arrow is showing, that is your front view. That will be there. Then, if you flip it, like the picture shows, that's how it's going to look on the left view. And if you take the front view and you turn it and to show the top view, that is how it's going to look. Let me just get the focus up. Okay. We are not going to do the original third angle orthographic projections yet. Yeah. Okay, so to draw something like this, it is quite easy if you just look at how they want you to draw it. That is why different lines is important. You see how there is these center lines here. Those center lines that goes from side to side and up and down are these center lines that you see here. So that will help you to match up to see that center line is that center line just from the side. And this center line is basically this center line from above. Okay. Now, the important thing is you'll see if you draw the top side and you draw it above my front view, you'll see how the distances match up. And that is why we draw it in this way. Okay. So let me show you. This is basically let me just use this one. It's less scribbled on. All right. This is basically the original how you start. So what's given is your top view and front view of a machine piece, okay? This is your top view because your top view will usually be at the top, okay? It's quite obvious. All right. And then your front view is here below it. And you'll see how the distances match up exactly, meaning this one that says 50 millimeters will mean this one's 50 millimeters as well. So oftentimes they'll give you measurements at the bottom, but you need to use it again at the top. When you draw an orthographic projection, you'll see this cross that I made pink. They give you a starting point already. So that cross is the center of this top view. So you are going to draw this as you see it, exactly using the right measurements around this cross. And then once you are done, you do the front view. But the front view, let me just, there we go. But the front view is going to be just below it. To calculate what the distance needs to be between your top and front view, it will always either be 5 millimeters or 10 millimeters. I used to do it in 10 millimeters, but if you run out of space, it needs to be 5. Okay, so from this line to this line needs to be 10 millimeters. Do you understand? So I want you to draw this one, but I want you to also use common sense now. A lot of kids ask me, ma'am, what's the distance between these two lines? The first line's curve is 16 millimeters. The second line is 14. 16 minus 14 is 2 millimeters. Okay, so your lines are 2 millimeters. What I want you to focus on today is first copy this, what you see, but also add the hidden details. Add also the center line so you can use it and use it correctly. Okay, you saw it. So I just want to show you. This is basically how you are going to draw orthographic in the future. Okay. Guys, Okay, the important thing that you need to note is you'll see there's the front view of this object, there's the top view, and there's the side view. All right, that is why in the future you need to make sure everything is always 10 millimeters from the side, or 5 millimeters depending on your space. And why you need to add hidden detail, because if I gave you this drawing, just this drawing from the top, but did not give you any hidden detail, you'll see it's like 3 lines and nothing else. But the hidden detail is able to tell me there's stuff that is happening inside but you can't see it. And your hidden detail needs to be matching up with your other profiles. Okay, so meaning this line, if I take it up, it matches up with that line. This circle, if I carry it through, it's matching up with the hidden detail there. That line there, if I take it up, it matches up with my hidden detail given there. All right, and my center line matches up with the one at the top. The same goes for the side. If I take this all the way to the side, my circle, hidden detail is there. Center line's there, hidden detail, everything's there. Eventually, I'm going to show and remind you, but you don't need to do this now. We are going to start doing cutting planes. Cutting planes means you take a drawing and you cut it in half and you draw it as such. All right. Yeah, then it becomes complicated. So then your drawing is going to start looking like this, where all the cutting is being shown with these, an orthographic projection. And there's more than 2 views, 2 perspectives. We project our drawings. Okay. Like I said before, when you draw, these things start to match up. For example, my sides here matches up with the sides there and there. So when they give me a measurement here, I know I can use it here as well. Does it make sense to you? Okay. But now, if you want to use this measurement, they give you this measurement, you can project it to there as well. Okay. Such as that. But the problem is, sometimes they give you a measurement here, but you don't know how to project it there. That is where your triangle of 45 degrees come in. What you will do is, the distance here is 5 millimeters and 5 millimeters. I usually draw a darker line, okay, to show that it's a little bit, that's my center line. Then you take your 45-degree triangle and you draw it straight up. Then when you project, let's say this side to the 45-degree triangle or the angle, I can just project it like so. Okay, so instead of projecting just to the sides, now I can project it to my 45-degree angle, and where they touch and meet, I can project it down, and that will be my same distance. Okay, so it's very important to start doing this, because a lot of the times all the information is going to be here, and you won't know what to do here. Okay, but this is for tomorrow when we start doing this. All I want you to do until then is you need to do